Welcome to a very special keynote presentation where every minute counts, every word counts, every discussion matters, and yes, even the vacuum matters. My name is Professor Saim, CEO of Sanyou London, and I'm here to give a meaningful, realistic speech on vacuum insulation energy saving technologies for building construction, retrofits, refurbishments, storage and transportation, and also for the AI, data centers, electronics, and automation sectors. In this keynote speech, we are going to have practical discussions for decision makers, real estate builders, architects, contractors, local suppliers, and distributors. These critical discussions will require your patience, your attention, and your precious fourth dimension time to achieve meaningful insights and impactful understanding about our future. So, our future is ideally thinking and asking the right critical questions at the right time, in the right place, under the right circumstances, and with the right inspiration. But we need realistic reason, the purpose, the aim, the why, and the problem we aim or want to or can solve. To begin with, who am I and what is my aim and why? So my aim is to unify academic research and development, industrial manufacturing, and product distribution to the global market. About myself, I'm specialized in electrical, mechanical, and renewable energy engineering, and one of my areas of expertise is vacuum insulation. Throughout my academic career, I have taught 41 modules at various universities at undergraduate and postgraduate levels, served as a course director for multiple programs, deputy head of the School of Engineering, professor of renewable energy engineering, external examiner, visiting professor, head of research group, and a worldwide public speaker collaborating with more than 40 countries. Having published over 140 research papers and supervised doctoral, masters, and engineering students, I have realized something unique, that academic research, however important it is, often stays confined to research papers or feasibility studies, rarely becoming practical solutions that truly help our society. That's why my team, our partners, and I decided to bridge this gap. We have turned decades of research knowledge and practical experience into innovative real-world solutions. Our goal is simple and clear: to create genuine energy-saving products that make a measurable difference, reducing energy consumption for communities around the world. Now, we are not only saving you money, we are helping you save your energy resources, allowing you to earn by saving. And it financially makes sense. Welcome to the real world. Our discussions are real, the struggle is real, our inventions and innovations are real, the products you are about to see are real, and most importantly, we are real. So let the adventure begin. Who are we? Sanyou London is the successful long-term UK-China business and industrial research and development collaboration in partnership with the world's esteemed manufacturer and leader in vacuum insulation technologies, Jiangsu Sanyou Dia Energy Saving New Materials. Why am I doing this? Because Sanyou is all about genuine quality, real innovation, highly competent team, intellectual positive decision making, and hard work, and of course results. We have established industrial mass manufacturing and R&D capabilities with annual output capacity of 2.5 million square meters, and is growing with ISO 9001-2015 quality management system certification, This ensures top quality standards through rigorous measurements and validation of thermal conductivity and patented technique of internal vacuum pressure measurements. Also, we have accelerated edging test. It also includes a specialized research lab equipped with cutting-edge tools and ISO standard instruments for studying electrical and thermal performance alongside a unique real-time performance house facility for in-depth analysis of energy, thermal and sound insulation in various climates. Our mass manufacturing and product achievements are vacuum insulation panel with flexible designs for various applications, decorative integrated vacuum insulation panel for external cladding, external wall insulation, or internal roof insulation, vacuum insulated wallpaper for internal wall insulation, internal roof insulation, interior insulation for various applications. And we have vacuum insulated bag or box that consists of vacuum insulated medical box, DeepCold box, rolling card cover, and fresh bag for transport and storage of medical, food, and logistics applications. We have recently launched Vacuum Insulated Curtain, where you don't need to replace windows. It is a DIY, minimizes cooling, heating, energy loss. It installs just like a normal curtain. And our mass manufacturing and production achievements, which is going to be launched very soon in 2025, which is Vacuum Insulated Heatable Curtain that provides gentle radiant heating while effectively blocking cold transfer through windows. We successfully exhibited our innovative vacuum insulation products at Saudi Projects 2025, held at the Riyadh International Exhibition Center in Saudi Arabia. We received very positive appreciation from trade visitors, which has led to the development of ongoing business collaborations. Since our innovations are truly unique, we were the only ones who clearly stood out for both originality and practical value, especially in supporting progressive projects across Saudi Arabia. The strong interest shown reflects the growing recognition of our innovations in solving real energy challenges. But we need to discuss realistic reason, the purpose, the aim, the why, and the problem or challenges we aim or want to or can solve with our vacuum insulation energy technologies. As usual, we always start with this. Although we could talk about the semantics of it for hours and hours, to put it simply, climate change is scientifically linked to carbon emissions. Because of that, we now hear so many ideological terms such as go green, net zero, energy, net zero minus, zero emissions, sustainability, renewable energy, clean energy, low carbon, sustainable development goals, and so on. And mostly we end up with a tick box exercise, a checklist of jargon-filled ambitions ticked off one by one, while the real problems quietly continue to grow. It all sounds promising on paper, but in practice, very little changes unless we act where it truly matters. But the main purpose behind all of this is to find a genuine balance between reducing carbon emissions and meeting the rising global energy demand. Why? Because we are constantly building and expanding, and even population growth need to be supported. In fact, phrases like net zero have become the punchline in almost every research paper in the energy and built environment sector. Ironically, some of these papers end up increasing carbon emissions themselves. By running endless simulations that have little or no connection to what's actually happening in the real world, To achieve true balance, we must either generate more energy through renewable or non-renewable power plants, or we reduce energy loss. That's where insulation becomes crucial. And among all types, vacuum insulation performs the best, which we are going to examine throughout this keynote speech. A simple analogy is, imagine a bucket with holes. If we keep pouring water into it, we need more and more water just to keep it full. But if we reduce the holes, we obviously reduce the water loss. In this analogy, the water is energy in kilowatt hours. Approximate percentage of buildings that are not insulated. For example, my research indicates in the United Kingdom there are 20% buildings which are not insulated, Saudi Arabia 70%, UAE 50%, Italy 50%, Kuwait 20%, Qatar 50 to 60%, Germany 42%, Bahrain 60 to 70%, and Oman 90%. Now, higher the percentage, greater the cooling energy loss or heating energy loss depending on the climate. Approximate percentage of buildings that are partially or fully insulated. Again, my research indicates that in the United Kingdom, there are about 40% of the buildings which are either partially insulated or fully insulated. Saudi Arabia, 5 to 10%. UAE 50%, Italy 20 to 30%, Kuwait 50%, Qatar 10%, Germany 28%, Bahrain 10%, and Oman 10%. In this, lower the percentage, greater the cooling energy loss or heating energy loss. Well, of course, energy prices in the Middle East are much lower due to reduced tariffs, and the cost-benefit ratio may suggest otherwise. So aside from national initiatives on energy efficiency, why should we insulate if it only increases construction cost? A very important question. So the realistic reasons are, number one, reducing cooling energy loss lowers the air conditioning load, allowing it to turn off for short periods, which helps extend its lifespan and reduces expensive repair cost. Number two reason, from a nationwide perspective, reducing cooling energy loss cuts energy demand and conserves fossil fuels. Even a 10% saving could match the output of a renewable energy power plant. Number three reason, energy prices keep rising, yet buildings last for centuries, not for decades, not for 50 years, but for centuries. So the decision made today will impact generations. Look at what happened in the United Kingdom, where many homes remain uninsulated. Energy costs are among the highest globally, leading to the harsh choice between heating or eating. Number fourth reason is humanity naturally progresses forward from one innovation that was good in the past to another that is better for the present and the future until something even better comes along. At the moment, vacuum insulation is the present and the future. Now, imagine a residential building with no insulation in a hot climate, say 40 degrees Celsius. At the moment, in the month of June 2025, as I'm recording this video, the temperature in Riyadh is about 44 or 45 degrees Celsius. But let's imagine that when the air conditioning is on, it feels comfortable. There is nothing to worry about. But what happens when the air conditioning is off for a few hours during the day? That same space can eventually turn into a virtual oven. If the same building, for example, or if the building is made of beautiful shiny glasses, under the same conditions, it could easily turn into a virtual cooker. On the off chance you are a real estate developer or a building construction decision maker, here is a question for you. What is your unique selling point compared to others? Most new or old builds are marketed with usual talk luxury facilities, glossy brochures, and beautiful advertisements. But when a buyer asks a simple question, how is the building made? What materials are actually used in the apartment that I anticipate to buy, for example, the answer is often vague, with no clear specifics, a hollow promise rather than a solid response. But the fact remains, it's always the buyer, the customer, who ends up paying the energy bills. People who buy today will one day retire, and when regular income is no longer there, energy costs will still be part of their lives. It is something they will have to factor in during their pension years. That's why a building must be energy efficient and well insulated. Well, we use concrete and bricks in building construction, and of course, we must, because the buildings we constructed today are meant to last for hundreds of years. The decisions we make now will directly impact the lives of future generations living in those buildings. Take the United Kingdom as an example. We have thousands of heritage and older buildings built decades or even centuries ago. Many of them are now classed as hard to treat or hard to retrofit, and they consume far more heating energy just to keep the inside warm. With the UK now having some of the highest energy prices in the world, we are seeing the widely known phrase come to life, which is heating or eating, a harsh reality during the ongoing cost of living crisis. The concrete wall, let's begin with the thermal conductivity, which is a measure of how easily heat can pass through a material. If a material has a very high thermal conductivity number, like the concrete wall that has 1630 milliwatt per meter per Kelvin, it lets heat move through it quickly. U value, or thermal transmittance, is a measure of how much heat passes through a building element, like a wall, window, or roof. In this case, concrete wall has a higher U value of 3.4 watt per meter square per Kelvin. Lower the thermal conductivity or U value, better the insulation, lower the losses. This could mean that most of the buildings that we have in the United Kingdom are either solid brick wall, which has a thermal conductivity of approximately 840 milliwatt per meter per Kelvin and a U value of 2.3. It is slightly better than a concrete wall, but still far too much heat passes through it. We are going to examine all of it when we apply vacuum insulation panel. This cavity wall, which is quite normal nowadays for new building constructions, that has a thermal conductivity of approximately 380 and a U value of 1.5 watt per meter square per Kelvin. It is better than both solid brick and concrete walls, but there is still considerable energy loss, which we can and should be reducing. Later, we will see how these numbers can be reduced with vacuum insulation to levels that truly show what energy efficiency really means, or when we minimize the leakage of cooling or heating energy loss with it. So what are the limitations of the conventional insulation materials? Which are they and why? We are going to begin with our famous insulation. I hope we can settle this once and for all, EPS, expanded polystyrene, was invented in 1949 in Germany and has been widely used for insulation and packaging ever since. It's a type of thermoplastic polymer like this one, right? Like EPS and XPS, however, it is flammable and can catch fire easily, with a fire rating of class E according to the BSEN 135011 standard. Even when treated with fire retardants, its fire resistance remain limited. It has lower thermal performance compared to other insulation material. Furthermore, EPS degrades with exposure to atmospheric humidity and temperature, making it less durable over time. Additionally, it can attract insects like ants and spiders, and fungus or mold can develop on it. In expensive buildings, using EPS means future refurbishment costs must be considered, as it will likely need replacing after some years. It also needs more thickness to provide the required insulation, which takes up valuable space. Of course, EPS is cheap to buy and easy to cut on site, but its long-term performance and risk must not be overlooked. PIR insulation board is a type of thermostat polymer, a form of plastic. It offers better thermal resistance than EPS, but still needs to be fairly thick to achieve improved performance. PIR has a Class B fire rating according to the BSEN 135011 standard, which means it provides better fire resistance than EPS. However, it is still flammable and can catch fire under extreme conditions. PIR also tends to attract dust, and although it degrades more slowly than EPS when exposed to humidity or changing temperature, it still shows signs of wear over time. PIR is more expensive than EPS, and its bulkier size and heavier weight mean transportation costs must also be considered and are typically higher. That makes it a less cost-effective option in many cases. It can be cut on-site during construction, which is useful, but when you weigh up the higher price, transportation challenges, and the fact that it is still combustible and prone to long-term degradation, PIR becomes a less appealing choice for many building projects, despite its modest improvement in fire and thermal performance. Rock mineral wool is often praised for its higher fire resistance. It can achieve a Class A1 fire rating under BSEN 135011 standard, meaning it is non-combustible. However, beyond fire performance, there are important limitations to consider. First, it needs to be thicker in its size that require more space, and if we were to look at it microstructurally, mineral wool has an open fibrous structure that easily traps dust, moisture vapor, and airborne water particles. Over time, this creates an environment where insects can nest and fungus or mold can develop, especially in humid or poorly ventilated spaces. This may lead to unpleasant smells, reduced air quality, and degradation of insulation performance due to trapped moisture in it. While mineral wool performs well in fire resistance scenarios, its vulnerability to biological contamination and moisture related deterioration makes it less ideal for long-term enclosed applications, particularly where vapor control is critical. Similarly, glass mineral wool is widely used in building construction and is known for its non-combustibility, often achieving a Class A1 fire rating under BSEN ISO 13501 standard, similar to rock wool. Again, it needs to be thicker in its size that require more space. However, when we examine its practical and microstructural limitations, several concerns arise that are its open, fibrous structure makes it highly absorbent to moisture vapor, or even over time it can trap dust, dirt, insects, and airborne pollutants. However, moisture vapor is one of the important point that needs to be considered when it comes to the insulation. However, the lifeline is lower. In humid conditions or areas with poor ventilation, this can lead to fungus and mold growth, which may result in an unpleasant smell and compromise indoor air quality. The accumulated moisture can also increase thermal conductivity of the insulation over time, although it performs well in terms of fire resistance and initial cost. Glass wool is sensitive to environmental conditions. Without proper vapor barriers and maintenance, it may degrade, lose effectiveness, and become a source of biological contamination, making it less suitable for long-term sealed or high humid applications. This brings us to a very important discussion: what is vacuum? When we reduce the atmospheric air pressure or remove air molecules from 101.325 kilopascal down to between 1 pascal and 10 pascal, we create a moderate vacuum. This is the level we apply in our vacuum insulation energy technologies. What does the vacuum do? Well, it reduces heat transfer, that is vacuum insulation, meaning it saves energy. It reduces noise, that is sound insulation, meaning we could have a good night's sleep in a city center or in a busy large city centers. And it limits fire propagation, that is fire resistance. That means it minimizes the damage caused by unusual fires that can occur in any building. This brings us into the age of vacuum. Our premium vacuum insulation panel is flexible in design, offers the lowest thermal conductivity, delivers significant energy savings, reduces noise, and provides the highest level of fire safety. It's available in all dimensions, sizes, and shapes, fully tailored to your requirements. But what is vacuum insulation panel? It is an advanced insulation material made of a core, usually either superfine fiberglass with gutter and desiccant, or microporous fumed silica, dual edge sealed inside a gas-tight envelope. Inside this sealed panel, we create a vacuum pressure of less than 10 pascal, which greatly reduces heat transfer through conduction and convection. To reduce heat transfer by radiation, the panel is wrapped in a reflective aluminum barrier. To maintain the aging life of at least 25 years, we implemented gutter desiccant. A gutter absorbs non-condensable gases, oxygen, nitrogen, hydrogen, etc., that slowly diffuses into the vacuum space or are released from the core material over time. In other words, it minimizes outgassing. A desiccant absorbs moisture that permeates slowly through the barrier film over years. Both help maintain the vacuum pressure for at least 25 years, ensuring the insulation stays effective throughout its lifespan. The lifespan of our vacuum insulation panel is, according to our accelerated aging test, is at least 25 years. After then, thermal conductivity may slowly rise by a few percent as the panel continues to age, but it will remain be competitive amongst other insulation materials at that age. Our vacuum insulation panel comes in a variety of shapes such as triangular, hexagonal, rectangular, square with holes, cubic, semicircular, and other customized geometric forms. For example, I wish to show you some of the samples that we have. The only limitation is that you cannot cut VIP on site. It is why we can assess your project design, analyze the dimension details, facilitate measurements, and produce bulk units based on your requirements. For example, we can create hole in the VIP, allowing space in certain areas for electrical wiring and sockets. But why our vacuum insulation panel is so innovative and smart insulation compared with conventional insulation materials? To compare the thermal conductivity and thickness parameters, first, just to repeat myself, lower the thermal conductivity, better the insulation, and lower the cooling or heating energy loss. What we see here is our 15 millimeter thick fiberglass vacuum insulation panel has a thermal conductivity of 2.5 milliwatt per meter per Kelvin and a U value of 0.16, and 25 millimeter thick fumed silica vacuum insulation panel has a thermal conductivity of 4.5 milliwatt per meter per Kelvin with a U value of 0.17 watt per meter square per Kelvin. That evidently offer the best thermal performance, far better than any conventional insulation materials available today. For example, even at 250 millimeter thickness, rock mineral wool still has a thermal conductivity of 34. Similarly, glass mineral wool at 200 millimeter shows a thermal conductivity of 44. PIR at 180 millimeter thickness has a thermal conductivity of 22. And as for EPS, even at 100 millimeter, it reaches a thermal conductivity of 36 milliwatt per meter per Kelvin. So even at thinner dimensions, VIPs outperform all in terms of insulation, but again, what it means? It means that when you apply the vacuum insulation panel to this concrete wall, the effective thermal conductivity of the concrete VIP wall is reduced from 1630 to 35, a 97.9% improvement, while the U value drops from 3.4 to 0.159. This 97.9% improvement means that cooling or heating energy loss is reduced significantly compared to standard concrete wall. If we were to look at the solid brick wall, it also means that when you apply the vacuum insulation panel to this solid brick wall, the effective thermal conductivity of the solid brick VIP wall is reduced from 840 to 38 milliwatt per meter per Kelvin. That's a 95.5% improvement, while the U value drops from 2.3 to 0.155 watt per meter square per Kelvin. This 95.5% improvement means that cooling or heating energy loss is reduced significantly compared to standard solid brick wall. Furthermore, it also means that when you apply the vacuum insulation panel to the cavity wall, the effective thermal conductivity of the cavity VIP wall is reduced from 380 to to 41, a 89.2% improvement, while the U value drops from 1.5 to 0.15 watt per meter square per Kelvin. This 89.5% improvement means that cooling or heating energy loss is reduced again significantly when compared to the standard cavity wall. A similar analogy can be applied to various applications of vacuum insulation panel. Our vacuum insulation panel has a fire rating of class A, which refers to the reaction to fire rating of VIP or vacuum insulation panel, denoting a non-combustible material that contributes virtually no heat, flame spread, or smoke in a fire. It is the highest reaction to fire grade and broadly corresponds to the European National Standard 135011 grades A1 and A2. This brings us to the applications of VIP in electric and hybrid vehicles. Flexible VIPs can insulate dashboards to protect electronic screens and help maintain cabin comfort by reducing heating and cooling loads. They are also effective in managing battery compartment temperatures, supporting battery performance and lifespan. Applications of VIP in locally made materials. Flexible VIPs can be seamlessly bonded to local products in a particular country, like tiles, stone decorative coverings, or facade panels, without altering existing manufacturing lines. By integrating VIP into these finishes, manufacturers deliver premium, net zero ready products without added thickness or design compromise. Developers gain a strong selling point, luxury surfaces that lower HVAC loads and energy bills, while contractors avoid added wall depth or crane weight. A simple bonding station offers high margins and positions local suppliers as leader in sustainable high-performance construction. Application in transportation and industry trucks and containers. Flexible vacuum insulation panels improve insulation in large trucks and cargo containers, cutting fuel use, emissions, and energy loss, while helping preserve perishable goods during transport by maintaining stable internal temperatures. Applications in the construction sector. As we know, flexible VIPs can be integrated into building envelopes for superior thermal insulation in both residential and commercial structures, helping to minimize heat loss and reduce heating and energy and cooling costs. In retrofitting projects, they offer a practical solution allowing efficient insulation upgrades without major changes to the building's structure. Applications in refrigerators and HVAC piping. VIPs improve refrigerator efficiency by reducing heat transfer through walls, easing compressor load, saving energy, and freeing internal space. In HVAC systems, wrapping pipes with thin flexible VIPs can cut energy loss by over 90%, prevents condensation, and fits neatly into tight spaces. And it delivers high performance without bulky insulation. Applications in AI factories, data centers, electronics, and automation. In artificial intelligence factories, data centers, and electronics enclosures, thin flexible vacuum insulated panels can be applied around server racks or control boxes to stop heat buildup, maintain safe and steady temperatures, and extend equipment lifespan, all while reducing cooling energy use. In industrial automation systems, flexible VIPs support better thermal management and energy efficiency, helping improve system performance and lower operational costs. For more details about the vacuum insulation panel with flexible design, please visit www.sanyoulondon.com. So you can also download the product catalog by scanning the QR code. When we look at available solutions for external wall insulation or external cladding, the idea is simple. Instead of stacking and fixing multiple separate layers, such as insulation board, vapor barrier, fire sheet, and outer finishes like stone or brick, we propose an integrated alternative. Our new revolutionary all-in-one solution for external cladding, external wall insulation, and internal roof insulation, which is Decorative Integrated Vacuum Insulation Panel, DVIP. The Decorative Integrated Vacuum Insulation Panel is available in all dimensions, sizes, and shapes, customizable to your requirements. It has a thickness of 30 mm with a thermal conductivity of 7 mW per meter per Kelvin. The panel features mid-century modern MCM and metal type exterior finishes. Both MCM and metal type DVIPs feature Class A1 fire rating, 3D sound absorption, freeze-thaw resistance, anti-aging properties, and long-term durability that remains stable even over a century. They are fully waterproof, and more importantly, our accelerated aging tests confirm a lifespan of at least 35 years for this type of decorative integrated vacuum insulation panel. And after this period of after 35 years, the thermal conductivity may gradually increase by a few percent as the panel continues to age. To compare the thermal conductivity and thickness parameters, first, just to repeat myself, lower the thermal conductivity, better the insulation, and lower the cooling or heating energy loss. What we see here is our 30 mm thick decorative integrated vacuum insulation panel that has a thermal conductivity of 7 mW per meter per Kelvin with a U value of 0.22 that evidently offer the best thermal performance, far better than any conventional insulation materials available today. For example, even at 250 mm thickness, rock mineral wool still has a thermal conductivity of 34 mW per meter per Kelvin. Similarly, glass mineral wool at 200 mm shows a thermal conductivity of 44 mW per meter per Kelvin. PIR at 180 mm thickness has a thermal conductivity of 22 mW per meter per Kelvin, and as for EPS, even at 100 mm, it reaches a conductivity or thermal conductivity of 36 mW per meter per Kelvin, for XPS 33. So even at thinner dimensions, decorative integrated VIP outperforms all in terms of insulation. The MCM type decorative vacuum insulation panel, as shown here, has been experimentally installed in a test house. This MCM type decorative integrated VIP consists of 3 layers. A customizable front layer with mid-century modern decorative finishes, stone or different types of finishes are possible. A mid layer containing the VIP core insulation, and both front and back layers made of calcium silicate. Integrated anchors are also included to enhance structural reliability. It offers a selection of customizable patterns as indicated by numbers, but more range of colors patterns can also be seen. For varied decorative effects and a strong sense of artistry tailored to individual preferences with a layer of calcium silicate or wood fiber attached to the front side to protect the VIP core. I would like to draw your attention to the edges and the seamless precision cuts at this corner, which is this one. This is why having the dimensional details in advance is crucial. However, for hard to reach areas where on-site cutting becomes absolutely necessary, we offer a decorative matching front layer that can be cut together without the vacuum insulation panel inside. In this realistic photograph of the MCM type DVIP, we can see an electrical switch. We can either utilize the panel edges for wiring, or more importantly, we can have a hole prefabricated in the decorative vacuum insulation panel during production to allow easier installation of piping and electrical connections. The metal type decorative vacuum insulation panel as shown in here, I would like to show you the realistic sample. This is one of our premium metal type DVIP. This has been experimentally installed in a test house. This metal type decorative integrated VIP consists of 3 layers, a customizable front layer with aluminum or galvanized steel plated with surface decorative treatment, a mid layer containing the VIP core insulation, and the back layer made of calcium silicate. Integrated anchors are also included to enhance structural reliability. It offers a selection of customizable patterns as indicated by numbers, but more range of colors patterns can also be seen for varied decorative metal effects. Metallic gray type decorative VIP, metallic gold type decorative VIP. In this realistic photograph of the metal type DVIP, we can see an electric switch with a prefabricated hole underneath, made during production to allow easier installation of electrical connections. Here we see the smooth corners and attention to detail in our production of the metal type DVIP, where seamless finishes are essential. This image shows the complex edges of the metal type DVIP, demonstrating how the corners and joints are handled and how the DVIP fits within intricate structural designs. To conduct the experimental energy, thermal, and sound insulation performance analysis, House A was constructed using MCM Decorative Integrated VIP, while House B was built to the same shape and size but with homogeneous panels of identical thicknesses. The overall energy consumption of House A is about minimum 22% lower than House B. The rewarming test shows after 6 hours temperature rise of House A is about 15% lower than House B. The sound insulation test shows noise reduction of House A is about minimum 15 decibel quieter than House B. The installation process of the MCM type decorative integrated vacuum insulation panel consists of 8 simple steps. First, we start by marking the reference line on the wall to ensure correct alignment. Next, we apply the interfacial agent to prepare the surface. Then we spread the bonding mortar evenly. After that, the panel is carefully positioned onto the wall. Once in place, we pre-install the fasteners, followed by drilling the holes at the marked points. We then tighten the expansion anchors and fastening screws securely. Finally, we apply masking tape along the edges and seal them neatly with a high quality sealant to ensure a clean and reliable finish, as we have seen in the photographs. The installation process of the metal type decorative integrated vacuum insulation panel is nearly the same as that of the MCM type. The only key difference is that in this case you will need to remove the protective film from the panel surface as part of the final step, after the panel has been fully fixed and sealed in place. For more details about the decorative integrated vacuum insulation panel, including FAQs, visit www.sanyoulondon.com or download the full product catalog by scanning this QR code with your mobile phone. Now, what if we want to install insulation ourselves as DIY, do it yourself? This is a genuine issue, particularly in the United Kingdom and across many European countries. For instance, if a customer wishes to install any insulation product, the installation cost alone is often at least 3 times the cost of the particular product itself. In the UK, the shortage of skilled building contractors and the high cost of scaffolding make the situation worse. Homeowners may have to wait months, facing extended disruption as a result. Many customers choose not to insulate their homes at all and continue paying much higher energy bills, which directly contributes to the cost of living crisis in the United Kingdom. There is, in fact, huge potential in the UK housing market, because if homeowners properly insulate their properties, the value of their homes can rise significantly, alongside the energy savings they would gain. Our vacuum insulation wallpaper VIW is a true innovation. As you can see, these are the two samples that I would like to show you. Now, vacuum insulation wallpaper is a world's first wallpaper that uses an ultra thin vacuum insulation panel with a total thickness of just 4 mm and a thermal conductivity of 5 mW per meter per Kelvin. It is designed for DIY installation. All dimensions, sizes and shapes are fully customizable to suit your requirements. The standard sheet size is 200 mm by 200 mm, and this has been chosen deliberately. If one sheet is ever damaged, the effect is limited to a very small area, so the overall insulation performance is not compromised. Smaller sheets are also easier to transport, pack and handle, which helps reduce costs. For more details and frequently asked questions about this VIW and all other products, please visit www.sanyoulondon.com. Vacuum insulation wallpaper VIW is made up of 3 layers. The front layer is a customizable design surface available in any color or pattern to suit your interior decor. The middle layer is a 3 mm thick vacuum insulation panel that offers exceptional thermal resistance and helps reduce heat transfer. The back layer features a strong self-adhesive made from oil-based glue combined with a fiberglass mesh, ensuring a durable, secure bond to the wall surface. To compare thermal conductivity and thickness parameters, first, just to repeat myself, the lower the thermal conductivity, the better the insulation and the lower the cooling energy loss or heating energy loss. What we see here is that our 4 mm thick vacuum insulation wallpaper VIW has a thermal conductivity of just 5, which is remarkably low, although it has a higher U value of 1.3 watt per meter square per Kelvin due to its ultra-thin profile. Still clearly outperforms any conventional insulation materials when it comes to thermal conductivity. Now let's compare a 10 millimeter thick thermal insulated wallpaper that has a thermal conductivity of 74 milliwatt per meter per Kelvin. The 4 millimeter thick wall rock thermal liner shows 50 milliwatt per meter per Kelvin. Even at 250 millimeter rock mineral wool only reaches 34. At 200 millimeter glass mineral wool has 44. PIR even at 180 millimeter has a thermal conductivity of 22, and EPS at 100 millimeter still comes in at 36 milliwatt per meter per Kelvin. This means that when we apply vacuum insulation wallpaper onto a structured insulated panel SIP system, we can expect a 51% reduction in effective thermal conductivity. Likewise, applying VIW to a concrete or prefabricated wall could lead to an 87% reduction. For a cob wall, the reduction is around 61%. For a cavity wall, 42%, and for a single brick wall, approximately 71%. These reductions clearly demonstrate the strong potential of vacuum insulation wallpaper to minimize heating and cooling energy losses, ultimately contributing to significant reduction in energy bills. These proof of concept illustrations of the vacuum insulated wallpaper VIW showcases an energetic and modern look across various interior spaces, including the bedroom, dining area, lounge, and kitchen, with the white brick effect, yellow mesh marble effect, and oak wood effect. However, we have now partnered to offer a wide range of VIW front layer designs, patterns, and colors. For example, here you can see the product designs and codes for VIW stone finishes. Stone designs continued in this slide. The selection of calendared film designs, metallic film designs, and single pressure color designs. The range of single pressure color designs continues, showcasing more options available for VIW front layers. And here the selection of double pressure color designs and wood grain designs. VIW applications are pretty much suitable for homes and residential buildings, including living rooms, bedrooms, kitchens, and bathrooms. They are also ideal for commercial spaces such as offices, retail stores, and restaurants. In villas where both aesthetics and insulations are important, customizable VIW designs offer a practical solution. Due to its lightweight nature, VIW can also be applied in aircraft cabins, offering both thermal and acoustic insulation through varied outer layers. Additionally, VIW can be integrated into vehicle interiors to enhance insulation and minimize heat loss, cooling loss between the vehicle's interior and exterior environments. For more details about the vacuum insulated wallpaper VIW, including FAQs and installation instructions, visit www.sanyoulondon.com or download the full product catalog by scanning this QR code with your mobile phone. Now everybody knows what a vacuum flask is. It keeps hot tea hotter and cold milkshakes colder for much longer than ordinary glass or plastic bottles. The vacuum flask, also known as a thermos, was invented in 1892 by Sir James Dewar, a Scottish physicist and chemist. But what about transportation and storage of medical, pharmaceuticals, fresh and frozen food, logistics, fresh food at catering events, agriculture products, and food delivery services. Introducing Vacuum Insulated Bag or Box (VIBB), which is fundamentally an application of Flexible Vacuum Insulation Panel (VIP), the next generation vacuum insulation solution for temperature sensitive transport and storage in medical, food agriculture, and chemical logistics and services. All dimensions, sizes, and shapes are customizable to your requirement. However, standard dimensions and sizes are uh, medical box, deep cold box, rolling card cover, and fresh bag. It is engineered to maintain the internal temperature, either cold or hot, of the contained materials without the need for ice, refrigeration, or electricity for extended period of time. Now, recognizing the diverse range of applications, we have developed and differentiated the VIBB into four distinct types such as medical box, deep cold box, rolling card cover, and fresh bag. So I would like to show you the first, the medical box. So this is the sample product of the medical box, where we can place a range of medical and pharmaceutical products to maintain its temperature for a longer period of time. Now, this medical box is designed with plastic protective film on the outer surface, fumed silica VIP with polyurethane insulation with hollow board protective box for outside to cater to a range of medical storage and transportation needs. The performance of the medical box is that at ambient temperatures of plus 25 degrees Celsius, the internal temperature was maintained between 2 and 8 degrees Celsius within 6.13 days. By considering the contents which were pre-chilled to 2 degrees Celsius. The VIBB medical box is available in various sizes, capacities, and weight to meet different needs, and especially within the pharmaceutical industry. It is designed to maintain the required temperature for medications, vaccines, biological products, and specialized laboratory reagents or chemicals. Now I would like to show you deep cold box. This deep cold box, crafted from vacuum insulated bag or box VIBB materials, is available in both foldable and non-foldable variants. This deep cold box is designed with polyurethane VIP, which is about 5 times more efficient in terms of thermal insulation compared to EPS or XPS panels. The performance of deep cold box is that at ambient temperature of plus 30 degrees Celsius, the internal temperature was maintained between 2 and 8 degrees Celsius within 3 days by considering the contents which were pre-chilled to 2 degrees Celsius. VIBB deep cold box is available in various sizes, capacities, and weights to accommodate different requirements and has a number of applications such as in fresh and frozen food logistics, food distributors and retailers, for delivery of frozen products like ice cream, seafood, and prepared meals to retail locations, catering services, and e-commerce online businesses to transport ingredients and prepared dishes to event locations, farmers and fisheries for transporting perishable products and seafood to market or processing facilities. This is the VIBB variant rolling card cover, which is a versatile large size vacuum insulation solution designed for dual purpose task of maintaining both cold and warm temperature during the transportation of fresh and frozen foods. The performance of a rolling cart cover is that at ambient temperature of plus 35 degrees Celsius, the internal temperature was maintained below 10 degrees Celsius within 15 hours by considering the contents which were pre-chilled to 2 degrees Celsius. Due to its larger size, rolling cart cover is suitable for a variety of applications such as in catering and event management, to transport hot and cold dishes to event venues, maintaining the desired temperatures until serving, agriculture product transport, a mobile storage unit for farmers and grocers, preserving the freshness of the fruits, vegetables, and other perishable during transportation from farm to market or distribution centers. Emergency and disaster relief in situations requiring rapid deployment of food, water, or medical supplies to affected areas at appropriate temperatures. The Fresh Bag, a pioneering addition to the vacuum insulated bag or box. So this is a Fresh Bag tailored for modern on-the-go lifestyles and demanding food logistics. The performance of Fresh Bag is that at ambient temperature of plus 35 degrees Celsius, the internal temperature was maintained below 10 degrees Celsius within 5 hours and within 6.5 hours with refrigerant by considering the food was pre-chilled to 2 degrees Celsius. VIBB fresh bags come in various sizes, capacities, and weights to suit different needs. They are perfect for food delivery services, whether it's drivers, couriers, or even autonomous delivery robots, ensuring meals arrive fresh and warm. They are also ideal for outdoor picnics on sunny days or for keeping your groceries fresh after a gym session, for example. And perhaps most satisfyingly, they let you enjoy warm food after hiking all the way to the top of the mountain. For more details about the vacuum insulated bag or box, including product codes, designs, sizes, and FAQs, visit www.sanyoulondon.com or download the full product catalog by scanning this QR code with your mobile phone. Now, what is next? It is another reason, the purpose, the aim, the why, and the problem we aim or want or can solve with our vacuum insulation energy technologies. The next innovation will change the way we see and think about glazed windows. But first, we need to see it and we need to feel it for ourselves. These photographs were taken in Munich, Germany during my conference speech when I looked at the incredibly large windows in a different way in the middle of a bitterly cold winter. It became immediately clear that these windows were the main source of heating energy loss. This is a photograph I took during the peak of a very hot day in Dubai, just outside the hotel. You can really feel that such large windows, how impressive, are becoming major source of cooling energy loss. And here inside the hotel room, we see extremely large windows covered with basic curtains. As a result, the air conditioning units are running constantly, working without pause to maintain the internal temperature. And it is the same here as well. For the past 15 years, my research has centered around vacuum glazing, its design, construction, edge sealing, and thermal performance, and more. A quick search of my name Saim alongside vacuum will lead you to many of my published results. The logic has always been simple. Better windows mean reduced heat loss in cold climate or reduced cooling loss in hot climate. That means lower energy bills and a meaningful contribution to climate goals like sustainability and net zero. But in reality, applying that logic in real buildings, homes has proven incredibly difficult. From a scientific angle, the vacuum glazing industry continues to evolve, but progress is slow. Only a handful of manufacturers have achieved long-term reliability in edge sealing, which is my specialty, and even then, real world stress from transportation along with constant wind, moisture, and temperature cycles can lead to edge seal degradation. One problem solved often reveals another. In short, vacuum glazing is powerful, but it is expensive, fragile, and difficult to implement at scale. And local glass manufacturers and distributors still prefer you to use their double or triple glazed windows because this industry is standardized. What now I'm saying, you perhaps you need to keep your windows. You don't need to replace windows. Because replacing windows isn't just expensive and slow, it is often completely unrealistic unless the glass is broken and literally falling out. This is especially true in the United Kingdom, where around half of all homes remain poorly insulated, and where more than 500,000 listed buildings are legally protected under the Planning Listed Buildings and Conservation Areas Act 1990. These protections exist to preserve historical features, which means original single glazed windows cannot be replaced without listed building consent. And in many cases, this consent is refused. I've seen the first hand how landlords and homeowners abandon the idea of upgrading to energy efficient glazings, and especially more advanced options like vacuum glazing. Because once they are faced with installation costs 3 to 4 times higher than the product itself, long delays, and the disruption caused by scaffolding, even when you genuinely want to upgrade, it is often just expensive and time consuming. Now you don't need to replace the windows. A whole change of arguments and reasons. Vacuum insulation curtain is another innovation, is the world's first disruptive curtain with vacuum insulation. It delivers real energy savings without contractors, scaffolding, or structural changes, and is easy to transport and install as DIY. In other words, we are not here to disrupt the glass industry or replace your beautiful windows. Vacuum insulation curtain simply minimizes cooling loss in hot climates and heating loss in cold climates, making homes and buildings more comfortable and energy efficient. It is available in all dimensions, sizes, and shapes which are customizable to your requirements. Vacuum Insulation Curtain VIC first launched in Riyadh, Saudi Arabia at Saudi Projects 2025 exhibition. Our primary motivation for launching VIC was for Middle Eastern countries where energy conscious decision makers appreciate innovative ideas and act on them with a forward thinking mindset. In regions like Saudi Arabia, the United Arab Emirates, Qatar, and Kuwait, large buildings are dominated by expensive glazed facades that lose a tremendous amount of cooling energy. What a coincidence! The hotel where I stayed during the Riyadh International Exhibition Center had a view that perfectly highlighted the importance of the vacuum insulated curtain. Let's see how. This is the room where I stayed. It had a beautiful window, but to reduce excessive heat, exterior claddings were installed outside the window to block direct sunlight during the daytime hours. This cladding is permanently fixed on the exterior facade. This is the nighttime view from the same window inside the room. The lights are on, but the outside view is no longer visible. So I switched off the lights to experience how during the night we can no longer see through the window. After all, the whole point of having a window is to enjoy the outside view. But with exterior cladding permanently fixed to block excessive heat during the daytime, that purpose is lost. It was justifiable until now with the new revolutionary innovation of the vacuum insulated curtain (VIC). We bring back the purpose or true purpose of windows, the view, while still minimizing excessive heat from the glazed windows. In cities with higher cooling loads and glassy or glass heavy buildings, vacuum insulated curtain helps keep indoor space cooler by slowing heat gain through windows. Traditional curtains in places like Riyadh often look good but offer inadequate insulation, although it is also suitable for cold and hot climates as well. The VIC is a unique curtain that consists of a back layer and a front layer. The back layer is made of durable cotton and stitched with 200 mm by 200 mm square pockets. Into each pocket, users can place a removable 3 mm thick vacuum insulation panel. This back layer can also be installed within existing curtains. The front layer is made from decorative silk, satin, or polyester fabric, giving it the appearance of a regular curtain, and this front layer is fully customizable. The pockets are spaced 10 mm apart, allowing the curtain to slide and fold just like any standard normal curtain. To compare the thermal conductivity and thickness, just to repeat, the lower the thermal conductivity, the better the insulation and the less cooling energy loss in hot climate and less heating energy loss in cold climate. Our 7 mm thick vacuum insulated curtain (VIC) achieves a thermal conductivity of just 13.08 milliwatt per meter per Kelvin, remarkably low. Let's look at others. For example, a 10 millimeter thick thermal insulated curtain is 40 milliwatt per meter per Kelvin. A 3 millimeter decorative curtain is 65 milliwatt per meter per Kelvin. Blackout curtains at 8 millimeter are 35 milliwatt per meter per Kelvin. A typical 1 millimeter sheer curtain reaches 90 milliwatt per meter per Kelvin. That's why we had the exterior cladding. Even a 4 millimeter lined curtain shows 70 milliwatt per meter per Kelvin, and a modern blackout curtain at 6 millimeter has 50 milliwatt per meter per Kelvin. So in this case, clearly the VIC vacuum insulated curtain outperforms all of them in terms of the thermal conductivity performance. To compare U value or thermal transmittance performance, our 7 millimeter thick vacuum insulated curtain (VIC) achieves U value of 1.87 watt per meter square per Kelvin, which is significantly better than any of the existing curtains available today as shown in the comparative graph. To conduct indicative energy savings analysis for a hot climate using Riyadh, Saudi Arabia as the reference city, it is important to acknowledge the complexity involved. Here, energy savings depend on several factors: the type of glazed window, the air gap between the window and the curtain, the type of curtain used, and the cooling profiles. Full technical details are available in the product catalog. However, to summarize, by replacing conventional curtains with vacuum insulated curtain, energy savings can reach between 33% and 23% with single glazing, and between 20% and 28% with double glazing. To conduct indicative energy savings analysis for a cold climate using London, United Kingdom as the reference city, it is important to highlight the complexity again of the calculations involved. Energy savings depend on, again, several factors: the type of glazed window used in the United Kingdom, the air gap between the window and the curtain, and the curtain types and the heating profiles of the space, the number of days that heating is being used in a particular year. Full technical details are provided in the product catalog. However, to summarize, by replacing conventional curtains with vacuum insulated curtains, energy saving range between 30% and 13% with single glazing, and between 11% and 26% with double glazing in the United Kingdom. It is important to be transparent. Vacuum insulated curtain is still a beautiful curtain, as can be seen here in a room, not a sealed window system. As with all curtains, there are edge effects, minor thermal leakage around the sides. But even accounting for that, the performance speaks for itself. Vacuum insulation curtain is a breakthrough in soft layer thermal technology, bridging the gap between expensive glazing systems and accessible DIY solutions. Vacuum insulated curtain improves the thermal performance of guest rooms, lounges, and dining areas without affecting the design or requiring any building work. It quietly reduces heating and cooling costs and is available in elegant finishes to match luxury interiors. For example, it is also possible to retain your existing curtains and install only the vacuum insulated bake layer, which still delivers significant energy savings. For more details about the vacuum insulated curtain, including installation instructions, product codes, designs, sizes, and FAQs, visit www.sanyoulondon.com or download the full product catalog by scanning this QR code with your mobile phone. The Vacuum Insulated Heatable Curtain, or VIHC, is now fully developed, progressed from Technology Readiness Level 1 to TRL 9, and marks the world's first vacuum insulated heatable curtain that provides the vacuum insulation and adequate heating. Once again, a disruptive innovation and an extension of the VIC. It is scheduled for launch in 2025. Vacuum insulated heatable curtains offers all the energy saving and insulation benefits of vacuum insulated curtain, with the added function of providing gentle, targeted warmth directly from the curtain. It consumes about 1 kilowatt hour, 1 unit of electricity, when used for 3 hours. This makes it especially suitable for cold, arid climate regions such as the United Kingdom and European Union countries, where heating costs are high. This revolutionary curtain not only delivers comfortable warmth, but also effectively blocks cold infiltration through glazed windows. If you want the best, this is the best. We will make you a realistic, competitive offer that you would be inclined to consider it. We have an excellent and dedicated team, and we invite you to get in touch with our customer service team for further information, tailored price quotations, or to discuss your specific project requirements. You can explore our full range of vacuum insulation energy products, review details of the specification of each product, purchasing process, and browse our FAQs by visiting our website www.sanyoulondon.com. If you'd prefer a direct conversation, you are most welcome to contact me personally by email or by phone so we can discuss how our disruptive innovations can contribute to the success of your project. Let's work together to take a meaningful step forward in the evolution of energy savings by putting our vacuum insulation innovative solutions into action where impact truly begins. Thank you.